Okay, so here's the on your own problem, and I went ahead and replaced f of x with y, and then I interchanged x and y and got this. And then I tried to solve for y by clearing the fractions and multiply both sides by y. I cleared the fractions, and notice y was on both sides, so I went ahead and got it both on one side. There they are. And then in two spots, so I went ahead and factored out the y's. I pulled y out, so I get x plus 1 equals 3. Then divide both sides by x plus 1. Excuse me. Then y equals 3 over x plus 1, and then the inverse is this right here. I didn't check it last time, I was afraid of doing fractions, but it's not too bad to check. So let's say I go ahead and let x equal 2. If I put 2 in for x, this becomes 3 divided by 2, which is 1 and a half, minus 1, which would be a half, or 0.5. Now when I interchange it, I get 0.5 comma 2. I put 0.5 into here, I get 3 divided by 1.5. I use my calculator there. 3 divided by 1.5, and I get 2 back. I get the 2 here. So it does work when you check it. Okay, so let's see what happens when we try to find the inverse of a standard quadratic function f of x equals x squared. So if I do this by hand, I get y equals x squared. And so y would equal, when I interchange x and y, I get x equals y squared. When I try to solve for y, let me go ahead and reverse this so it looks like it's a little bit easier to solve for. When I try to get y alone, I get y equal plus or minus square root of x. When I actually follow the 4 steps and I went ahead and interchanged x and y and I solved for y, notice how I solved for y, this is no longer a function. How do I know that? Because my input an x value in here, I'm going to get 2 values for y. I'm going to get the plus or minus there. So, so I have a function here. This was originally a function. But when I try to find the inverse of it, the inverse is no longer a function. So f of x equals x squared doesn't have an inverse. So again, this is the function. It can input any x in there, I'm only going to get one y. When I try to find the inverse, and I do that, my inverse, quotation marks, really isn't an inverse because I get 2 values for y, so it's no longer an inverse. So every x I put in there, I get 2 values for y. Another way to look at this is to look at the f function that's up here. If I put in 1 for x, 1 squared would be 1, so I get 1, 1. If I put in 2 for x, I would get 2 squared, which is 4. So I get 2, 4. If I put in negative 2 for x, that would be what, negative 2 squared? That give me 4, so I get negative 2, 4. If I put in negative 1 for x, that would give me 1, so I get negative 1, 1, etc. Well, that is a function because when I input 1, I only get 1 out. There's nothing else that would give me another output. I put in 1, I only get 1 as an output. I put in 2, I only get an output of 4. Put in negative 2, I only get an output of 4. Put in negative 1, I only get an output of 1. If I do the inverse of it, if I undo it, not inverse, but if I undo it, I would get 1, 1, 4, 2, 4, negative 2, 1, negative 1, etc. Do you know that now when I undo my interchange all x's and y's, 1 goes to 1, but 1 also goes to negative 1. That's where this comes into play. I get 2 values for an output. When I input 4, I get 2 as an output, and I also get negative 2. So this is not a function. but there's no inverse. Okay, let's go ahead and graph this. Let's go ahead and graph this function right here. We know the function, we know it doesn't have an inverse. So this is one of those common graph that y'all memorize. 2, 1, 2, 3, 4. Okay, this is the function. If I input 1 for x, I'm only going to get 1 back out. If I put negative 1 in for x, I don't get 1 back out. Now, and it passes the vertical line test. If I run a vertical line up and down, so I can touch 1 point in the graph. Now, let's talk about how we find if a function has an inverse. A function f has an inverse that is a function f inverse if there is no horizontal line that intersects the graph of the function f at more than 1 point. So to have an inverse, if you have a function, it passes the vertical line test. So this is the vertical line. 1, 2, 3, 4. All these vertical lines only touch 1 point. So we know this is a function. But when I want a horizontal line through this function, do you see how it passes more than 1 point? That means it doesn't have an inverse. Okay. So let's go ahead and look at these problems here. Which of the following graphs represent functions that have inverse functions? So this is a function because it passes the vertical line test. Does it have an inverse? We're going to run a horizontal line through it. It only touches 1 point, so it has an inverse. This is a function because it passes the vertical line test. Does it have an inverse function? No, because when I run a horizontal line through it, it passes more than 1 point. So no inverse function. This passes the vertical line test. It touches 1 point when I run a vertical line, but it fails the horizontal line test because if I run a horizontal line right here, it touches more than 1 point. So this is a function, has no inverse function. This is a function, and it has an inverse because it only touches 1 point when I run a horizontal line through it. Okay, this one's not on here, but let's go ahead and, this is one problem I put on the test. If I were to put this graph on here, let me draw one real quick. In that same direction here, you would say this is not even a function. It doesn't pass the vertical line test. It's not a function. That's it. If you're not a function, you can't have an inverse function. So it's not a function, then you're done. Okay? Let's go back to this problem up here. And this, again, is a function, but has no inverse. Because it failed the horizontal line test. Now, if we were to erase this side of the graph, do you see how this would now be a function and it has an inverse? So as long as x is greater than or equal to 0, then f of x would have an inverse function. Basically, as long as x is greater than 0, so if I didn't pick this value for x or this value for x, then it would have an inverse function. We'll talk about more of that later. Okay, so let's go ahead and, on your own, go ahead and tell me which of these following graphs represent functions that have inverse functions. I'm going to go ahead and add another one in there. Okay, so go ahead and pause the video and tell me which of the following graphs represent functions that have inverse functions. Okay, so on your own, the first one, part A, this is a function. It passes the vertical line test. It doesn't have an inverse function because it doesn't pass the horizontal line test. Part B is a function, and it has an inverse. C is a function, it has an inverse function. The last one, this is not a function at all. Okay? There's a relationship between the graph of a one-to-one function f and its inverse f inverse. Because inverse functions have order paired with coordinate interchange, if the point AB is on the graph of f, then the point BA is on the graph of the inverse function. Remember how we interchange them. If one point is on the graph of f or one point is a solution to f, we talked about this earlier, then when you interchange it, it should be a point or solution to the inverse function. The points A and B and BA are symmetric with respect to the line y equals x. The identity function. I spelled that wrong. Identity function. Thus, the graph of f inverse is the reflection of the graph f about the line y equals x. Let's go to example 6. For some reason, this is the most missed question on all my exams, or on this exam, 3-4 semesters in a row. So, I want to make sure that you understand. So, given this graph in this figure, draw the inverse function. If you want to draw the inverse function, all you want to do is just interchange all the x and y. Remember, this is the function. It has an inverse. So, all you have to do is interchange all the x's and y's, and then you have your inverse function. This is -3, -2. So I'm going to do -2, -3, which go right there. This is -1, 0, so do 0, -1. This is 4, 2, so I want 2, 4. This would be the inverse function. Notice how it's symmetrical across this line y equals x. Y equals x is right here. Oh, sorry. Y equals x is this line right here. Okay, so it's symmetric across the y equals x. Okay, let's go to example 7. And let's find the inverse of f of x equals x squared minus 1 if x is greater than 0. We're going to do this both algebraically, and we're going to do it both in the graph. So I'm going to go ahead and stop the video now because I think we're going to run more than 2 or 3 minutes, which is all I have left in the video. This will be the first example I do in the next part.